Turbine section of gas turbine engine. Part 3. The remaining element to be discussed concerning turbine familiarization is the turbine casing or housing. The turbine casing encloses the turbine wheel and the nozzle vane assembly, and at the same time gives either direct or indirect support to the stator elements of the turbine section. It always has flanges provided front and rear for bolting the assembly to the combustion chamber housing and the exhaust cone assembly, respectively. Inspection for cracks in turbine section components is very important. Cracks are not normally allowed. Crack detection when dealing with the turbine disc and blades is mostly visual, although structural inspection techniques can be used, such as penetrant methods and others, to aid in the inspection. Cracks on the disc necessitate the rejection of the disc and replacement of the turbine rotor. Slight pitting caused by the impingement of foreign matter may be blended by stoning and polishing. Because of the extreme heat under which the turbine blades operate, they are susceptible to damage. Strong light and a magnifying glass are used for inspection of turbine blades for stress rupture cracks and deformation of the leading edge. Stress rupture cracks usually appear as minute hairline cracks on or across the leading or trailing edge at a right angle to the edge length. Visible cracks may range in length from 1/16 inch upward. Deformation caused by overtemperature may appear as waviness and/or areas of varying airfoil thickness along the leading edge. The leading edge must be straight and of uniform thickness along its entire length, except for areas repaired by blending. Do not confuse stress rupture cracks or deformation of the leading edge with foreign material impingement damage or with blending repairs to the blade. When any stress rupture cracks or deformation of the leading edges of the first stage turbine blades are found, an overtemperature condition can be suspected. Materials such as metals and plastics also experience creep. This is a slow structural deformation on a molecular level caused by prolonged exposure to high stresses. The extreme temperatures in the turbine area of a turbine engine promote creep in turbine blades. Creep increases with temperature and can result in observable dimensional changes to the blades. Therefore, dimensional inconsistency could be caused creep rather than overtemperature. Blades should be inspected and measured in accordance with manufacturer's instructions. Signs of scoring on the turbine case may indicate the length of turbine blades is out of tolerance. Adhere to all manufacturer's specifications when observing and measuring blade deformation. Replace any damaged turbine blades as specified. Check the individual blades for stretch and the turbine disc for hardness and stretch. Blades removed for a detailed inspection or for a check of turbine disc stretch must be reinstalled in the same slots from which they were removed. Number the blades prior to removal.